We had earlier studied in the properties of electric charge that the magnitude of charge transferred delta Q is always an integral multiple of the electronic charge. That means when charge is transferred from one body to another, there is always the movement of electrons from one body to another. Now, if I bring two bodies in contact, I have here body A and body B, and in body A, let us say, I have some freely moving electrons available. If I bring these two bodies together and they're touching each other at a point of contact, these electrons can transfer from A to B. This process of charge transfer, when the electrons move at the point of contact from one body to another, is called the process of conduction. And in certain materials, the process of conduction happens very easily. That means the number of electrons that move from one body to another is very large. For these types of materials, we call them conductors. Examples of conductors include metals like aluminium, copper, iron. When we bring these metals in contact with each other, and if they have some freely moving electrons available, electrons can easily jump from one body to another. Whereas in certain bodies like insulators, the electrons cannot readily move from one body to another. The amount of charge transferred is quite negligible, and we often consider it to be close to zero. These bodies, called insulators, their examples include plastic, rubber, glass. Even if I bring these bodies in contact to conductors like metals, the number of electrons that will move from the conductor to the insulator or vice versa will always remain very small. However, there are still certain other processes through which there can be charge transfer in the case of insulators. That's what we'll study next. So you must be wondering what all these balloons are doing lying on our blackboard. But I haven't used any kind of a glue or a tape to stick those balloons up here. They are sticking here because of a concept called charge transfer by frictional electricity. How this really works, I can show it right here. I just have to rub those balloons on my hair, and when I place them on the board, they stick like this. How this works is what we'll study next. So now, using this simulation, we can understand how charge transfer takes place through friction. Here, if I bring a neutral balloon close to a neutral sweater and rub the balloon on the sweater, I can see that the electrons from the sweater are moving to the balloon. This transfer of electrons from balloon to the sweater creates a net positive charge on the sweater and a net negative charge on the balloon. Due to this, even if I bring the balloon slightly away from the sweater and I leave it, I can see that the balloon is getting attracted towards the sweater. So we had seen how by rubbing a balloon to a dry object like a sweater, the electrons from the sweater get transferred from the sweater to the balloon, hence creating a positive charge on the sweater and a negative charge on the balloon. Now what happens if I bring this charged balloon close to a neutral object like, for example, a wall? I can see that the balloon is getting attracted to the positively charged sweater, but if I bring it to a neutral wall, what I see here is that the electrons in the wall, which can move freely, are getting repelled by the negatively charged balloon. This movement of electrons away from the balloon creates a net positive charge in the area of the wall that is close to the balloon. This positively charged area of the wall and the negatively charged balloon attract each other, and hence if I leave the balloon at the wall, at the place, I can see that the balloon will stay at that place on the wall and it will appear as if the balloon has kind of stuck to the wall. So we saw how bringing a negatively charged balloon close to a wall led to the creation of charges on the neutral wall. Some electrons were shifted away and hence positive charge appears on the wall, and this led to the attraction between the wall and the balloon. This process is basically called induction, and this is very different when compared to, let's say, a charge transfer through conduction or by rubbing two materials, because here there was no contact between the balloon and the wall. The redistribution of electrons happened without any contact in this case. Also, the wall, which was neutral before we brought the balloon close to it, was neutral even after these charges appeared, because the amount of negative and positive charges are equal and they cancel each other. So no net charge is created in the process of induction. And the force between the neutral object and the charged object in case of induction is always attractive in nature because these charges are of opposite signs. Another example of induction was what we saw earlier when I used a scale and when I rubbed it against my hair. Due to charge transfer through friction, some electrons moved from my hair to the scale, thus making the scale negatively charged. And when I brought this scale close to a flow of running water, I saw that again because of process of induction, water, the positive charges of the water got attracted to the negatively charged scale, and hence we saw how the water stream was bending towards the scale.